Hi guys, see you again. I am Shengan from Hangzhou Firstack Technology and I am the technical marketing from Firstack. Today we will continue our open course and I hope you will enjoy our open course. If you think the video is helpful for your study and work, please don't forget to subscribe us and follow us. So now we can start the course. Hello everyone, welcome back to our open course. Today is our third lesson. If you missed the first two videos, I suggest that you can watch them first because the basic background and knowledge of double pulse test have been already included in these last two videos. If you don't have any idea about double pulse test, it will be hard for you to understand today's contents. And this lesson will be divided in three parts. In first part, we will go through the basic of three-level system. In the second part, I will explain how we complete the double pulse test of three-level system. And in the last part, we will introduce you a special topic about the short circuit test of three-level system. Okay, let us start today's lecture. There are two common types of three-level system, T-type and I-type. The topic today is the TPT of T-type three-level system. As you can also realize that in the last two lessons, we are talking only about two-level system. However, in actual application, three-level system is widely used in different areas. Therefore, this time we will discover the technical details and learn how to process TPT of three-level system. Great. Now we can go to catalog first. The contents of this topic are divided in these four chapters. Four structures of T-type three-level topology and the operation status of it. The third chapter is about the double pulse test method, which will be included in our second part of this video. And the last chapter is about short circuit test method, which will be included in the last video. Now let's go to first chapter for structures of T-type three-level system. The first one is shown in left figure, as we can see that in the left topology, T1 and T4 is similar to the two-level system. It is like a half-bridge structure, and based on this half-bridge, we add two extra IGBT named as here T2 and T3 on the left. If we take a look in the connection here carefully, the emitter of T2 and T3 are connected together. You can call it common E-type. This is also the most common structure of T-type three-level system. And then we can take a look into the right topology. The general structure is similar. The difference here is that not emitter connected together, but collector. So we can call it common C-type topology. These two topology occupy almost 95% of the actual application. Besides these two common topology, there are another two derived topology. So the first one we can go to the slide is shown here in the left. T1 and T4 are same. The difference is that two diodes are here used as a block of the power, and these two IGBT are connected quite similar compared to paralleling. And the last topology we want to share with you is from Fuji. Fuji is a famous power module manufacturer, as I know that they are the only one who uses this kind of topology in the worldwide range. And this structure is very unusual based on their special technology, which is RB-IGBT, reverse blocking IGBT. So what they have done here, they connect two IGBT chips directly as one here, and even further they can be connected in reverse parallel, so that they can realize this topology. And the idea from Fuji is that by the combination of a lot of this kind of component, a higher current carrying capacity can be possible, which means, in other words, the efficiency of our system can be higher. This is a special design, and we must say it is a really talented idea. Right now, maybe you will have also a question why we need three-level system. If we go back to the first slide from this figure, you can see there are two caps. You can imagine that we have two DC voltage to our IGBT respectively here. How we do it? We do it by adding an extra voltage level here, marked as 0. You can imagine it like our reference ground of our system. The top and the bottom side are still DC plus and DC minus. We use 1 and -1 to represent them. The benefit is that each IGBT only needs to effort half of the DC voltage. On the same DC voltage level, the energy loss of each IGBT is much lower than two-level system. From the equation here, I write here, P is equal, the power is equal voltage times current. We can find that. And also, the output voltage of three-level system is closer to a sine wave, which means we get lower ripple voltage. There are also some other benefits. If you have interest, we can also introduce three-level system deeper in the future video series. So today I just go through with very general introduction of it. Okay, these are the 4 most common topology we can find in actual application. The next chapter is about the operation status of three-level system. It is hard to handle all of these 4 topologies, so we choose the most common used structure to show you how three-level system works. It is also helpful for us to process the DPT and understand when and what parameters need to be measured during the test. Okay, in this slide, I make a logic table of three-level system, which need to be remembered. It's very important. The complete topology consists of 4 IGBT T1 to T4. I think you still remember in the last 2 slides I have already introduced them, and the corresponding diode of them, and also 2 caps C1 and C2. So we can go back to this slide and take a look. Now, this is the topology, and we use their gate voltage VGE to represent their working status, because from gate emit voltage we can know if this IGBT on or off. So here 1 represents on and 0 is off, and we can log into this table if we want to let our system start working. At least 2 IGBT must be on. I will explain why later in the coming part. So therefore, from this table, we can find 5 different operation status, 3 stable status and 2 dead time status respectively. Also, we can use hexadecimal to represent them. I'm not so sure if you know how to do it, but anyway, I can explain simply here. Let us use, for example, this first status 1100. This is like the cube of 2 plus 2 times 2, and it is equal 12. But we don't have number 12 in hexadecimal, so we use A, B, C, D, E, F, G. A is like 10, B is 11, so C is 12. This is what we have here, so the other status bit can be calculated in this way with same principle, and you will get C462. Just calculated them based on the same calculation principle. Yeah. So from this logic table, we can realize that the control logic of 3-level system is more complex than 2-level system, which has only 2 status. Now for 2-level system, you have only top on, bottom off, or bottom on, top off. So this kind of complex control logic, we can say this is a disadvantage of 3-level system. Okay, great. This is our logic table, and in next slide, I prepared a short conclusion for you. So totally, 4 IGBT have switching action, 4 diode have freewheeling and the reverse recovery process. So totally 8 components need to be tested in the double pulse test. Now you have a general view in 3-level system. In next part, we will go to more details. We will discuss how it works under different status and explain the test method. So see you in our next part. Bye.